Chapter 8 Gravitation. In last lecture we have discussed about Kepler's 3 laws in one example. Now today in this lecture we will see universal law of gravitation. Yes, you know one story. Apple falling from tree observed by Newton. Yes, actually that thing inspired Newton to propose one of his universal law of gravitation, and which also led towards laws governing terrestrial objects. So yes, Newton, he suggested or he gave one reasoning that moon, which is revolving around earth, has centripetal acceleration of moon. Centripetal acceleration of moon due to gravity of earth. Am is equal to, yes, we know equation of centripetal acceleration. Centripetal acceleration means it is v square upon r. So it is v square upon r. Centripetal acceleration of moon, radius of moon, v, that is speed. And now we know that for one revolution v is equal to 2 pi r upon t. 2 pi r upon t. Yes. So yes, if we put data in this equation, we will get it is 4 pi square. It is 4 pi square Rm divided by yes, Rm square divided by, here it is Rm into Tm. So is equal to, it is 4 pi square Rm upon Tm square. Clear? 4, that is 4 pi, that is pi. Radius of moon was known, time period of moon, that is already known. So yes, by putting this all value, you can easily calculate what is value of Am. Now, the interesting thing observed by Newton was this acceleration, centripetal acceleration of moon. This centripetal acceleration of moon, Am, is very small compared to centripetal acceleration of moon, Am, is very small compared to gravitational acceleration G on surface of earth due to gravity of earth. Yes, you know what is value of G, that is 9.8 meter per second square. So yes, he calculated centripetal acceleration of moon due to gravity of earth, Am. Value of gravitational acceleration on surface of earth, Ge, was known. So by comparing these two values, he suggested that the gravitational force of earth decreases with distance. Yes, he suggested that, or he observed that gravitational force due to earth decreases with distance. distance. Okay, it was conclusion. Okay, he suggested that gravitational force due to Earth decreases with distance because see, Moon, it is at large distance from Earth, and GE means gravitational force on surface of Earth. Okay, so yes, as distance increases, gravitational force decreases. If one assumes that, if one assumes that gravitational force is inversely proportional to square of distance, if one assumes that gravitational force is inversely proportional to square of distance, then we can say acceleration of Moon is proportional to 1 upon Rm square, while GE, that is gravitational acceleration on surface of Earth, is proportional to 1 upon R square. And if we find ratio, that is Am upon GE, so is equal to it is Re square upon Rm square. Okay, so it is ratio, it is comparison actually. Okay, acceleration of Moon divided by acceleration of object on surface of Earth. Clear? Okay, yes, its answer was approximately. Its observation, Newton lead towards the universal law of gravitation. What is universal law of gravitation? See, universal law of gravitation. Newton's universal law of gravitation. What is statement? Every object in universe attracts every other objects. Every object in universe attracts every other objects with a force which is directly proportional to product of their masses and inversely proportional to square of distance between them. Okay, again we will read this statement, that is every object in universe attracts every other object with a force which is directly proportional to product of their masses and inversely proportional to square of distance between them. Yes, inversely proportional to square of distance between them. Now how to see mathematical representation of this equation? Okay, how to see mathematical representation of this equation? See, if two point masses M1 and M2 are placed at a distance like this. If it is one point mass having mass M1, it is another having mass M2. Distance between them is R. Then what is meaning of this? See, every object in universe attracts every other object with a force which is directly proportional to product of their masses, means force which is directly proportional to product of their masses and inversely proportional to square of distance between them, means 1 upon r square. F is proportional to m1 m2 upon r square. F is proportional to m1 m2 upon r square, and that's why it is called inverse square law. It is also called inverse square law. Why inverse square law? Because F is proportional to 1 upon r square. F is proportional to 1 upon r square. Now if we remove proportionality, we have to add some constant. So therefore F is equal to G m1 m2 upon r square, where G is called universal constant, universal gravitational constant, universal gravitational constant. Now see why this law is given universal name, universal law of gravitation, universal gravitational constant. Universal means this law applies everywhere for each and every object in universe. See this statement, every object in universe attracts every other object. That's why it is called universal law of gravitation. This G, which is called universal gravitational constant, its value is constant everywhere. Its value is constant everywhere. That's why it is called universal gravitational constant. G. Clear? Now, yes, G. If we make it subject, then G is equal to, it is F r square upon m1 m2. So we can easily find what is its unit. Okay, so unit of G is equal to, it is F force, its unit is Newton, R meter square, m1 m2 mass into mass, means it is kg square. So it is how to for unit of G. Unit of G is Newton meter square per kg square, or you can also write Newton meter square kg raised to minus 2. Newton meter square kg raised to minus 2. Clear? Okay, so yes, F is equal to G m1 m2 upon r square, and yes, one most important thing, every object in the universe attracts. Gravitational force is always attractive. Gravitational force is always attractive. Gravitational force is always attractive. Gravitational force. Gravitational force. It is always attractive. So yes, this point you have to remember. One another point to be remembered. This gravitational force acts on the line joining two particles. This force acts on the line joining two particles. Here I will write force acts on line joining two objects. On line joining two objects. It is one most important statement. Okay, a force acts on line joining two objects. Clear? So yes, what is universal law of gravitation? Every object in the universe attracts every other object with a force which is directly proportional to product of their masses and inversely proportional to square of distance between them. Force acts on line joining two objects. 2 point masses m1 and m2 are placed at distance r, as shown in figure. So force is proportional to product of their masses and inversely proportional to square of distance between them. To remove proportionality, we have to add some constants. So F is equal to G m1 m2 upon r square. If you make G as subject, then you can easily find its unit. Okay, yes, from this you can also find its dimensional formula. Okay, G is called universal gravitational constant. What is its value? That we will see in next theory. Okay, so yes, it is universal law of gravitation and it is its scalar form, only magnitude. Now, force, you know that force is vector quantity. We know that force is vector quantity. Yes, vector quantity. Then, what is vector form of universal law of gravitation? That we will see. Now we will see vector form of Newton's law of gravitation. Vector form. First of all, as it is vector form, we have to select one frame of reference. Next, it is frame of reference X, Y, Z perpendicular to what coming outside. It is origin. So let we have two masses, M1, M2. Okay, yes. Their position vector with respect to origin R1 and R2. Clear? Okay, yes. Force is vector quantity. Force is vector quantity. So how to write any vector quantity? Vector quantity is equal to magnitude into unit vector. Okay, so see here, first of all, I will find force acting on particle M1 due to M2. Okay, gravitational force. Gravitational force acting on particle M1 due to M2. See how to write. F12. Force acting on 1 due to 2. Force acting on 1 due to 2. Force acting on 1 due to 2 is equal to. First of all, it is magnitude, that is G M1 M2 upon R12 square. What is R12? Distance between 1 and 2. Distance between 1 and R12 square. And here you have to write R12 caret. Here you have to write R12 caret. What is R12? R12 caret is unit vector in direction of force. In direction of force F1. Clear? Hello? Clear? Again, force acting on M1 due to M2. Force acting on particle M1 due to M2. How to write equation? That is important, okay? F12 is equal to G M1 M2 upon R12 square, R12 caret. R12 caret is unit vector in direction of force F12. Clear? Okay. Now we have to find what is R12 caret and R12. For that, see. Force acting on particle M1. Force is acting on particle M1 due to M2. Remember, gravitational force is attractive force. Gravitational force is attractive. Attractive means towards. Attractive means towards. On this chalk, gravitational force is acting due to Earth. Due to Earth. So if I release this chalk, it is moving towards Earth. Yes or no? Yes. Okay. So what is meaning of towards? See, force acting on particle M1 due to 2. It is towards M. Clear about this? So it is F12. Okay. So yes, I can write one another position vector R12 in this direction. R12 in this direction. Yes. Force acting on 1 due to 2, it is in this direction. So I am assuming one another position vector R12 pointing from 1 to. Now remember chapter 4. Yes, chapter 4, vectors. Vector addition, graphical method or triangle method. If you are given 3 vectors, then what is relation between them? See here, you have 3 vectors R1, R12 and R2. So identify relation between them. Yes, that tail, head. Okay, here it is tail. Here it is tail. Head. Tail, head. So if you remember how to write relation between them, so I can write easily from figure. See here it is tail, head. So you have to add these 2 vectors, that is R1 plus R12, and it is your answer, that is R2. Okay, so make R12 as subject. So R12 is equal to R2 minus R1. R2 is equal to, it is R2 minus R1. How to find its magnitude? How to find its magnitude? Magnitude R12 is equal to mode of R2 minus R1. It is mode of R2 minus R1. How to find unit vector? How to find unit vector? That is R12 caret. It is nothing but vector upon its magnitude. Vector upon its magnitude. Okay, yes, I can also write this as R12, its magnitude. So is equal to, it is vector R2 minus R1 upon mode of R2 minus R1. Clear? Okay, so again, two particles having masses m1 and m2, position vector r1 and r2. Gravitational force acting on particle m1 due to m2, that is F12 is equal to G m1 m2 upon r12 square, where r12 is distance between them. Means this distance, this r12 is distance between m1 and m2. R12 caret, where r12 caret is unit vector in direction of force F1. Now, how to form relation between r1, r12 and r2 with the help of triangle method? With the help of triangle method for vector addition. So yes, R1 plus R12 is equal to R2. So R12 is equal to, it is R2 minus R1. Its magnitude, its unit vector. Clear about this? Clear about this? Okay. Now you may ask me one question, sir. Only force acting on particle m1 due to m2? No. Every object in universe attracts every other object in universe. So yes, here gravitational force acting on particle m1 due to m2, you can also write equation for force acting on m2 due to m1. Yes, we will write, see here, gravitational force acting on m2 due to m1 with very small changes. You have to write equation, that is F21 force acting on 2 due to 1, G as it is, m1 m2 as it is. Here it is R21 square, here it is R21 caret. Simple? Yes. G m1 m2 upon R21 square, R21 caret. Where again, what is R21? R21 is unit vector along F21. Along F21. Clear about this? Clear about this? Okay. So now, what is direction of F21? F21 again, attractive force means towards. Attractive force means towards. If force acting on 1 due to F12, it is in this direction. Force acting on 2 due to 1 is in this direction. F21. F21. Clear about this? So yes, obviously R21 is also in this direction. R21 is also in this direction. Yes or no? Yes. Actually, you have to draw this thing here. Okay. But I am explaining this all things in one figure. Okay. So yes, see, from figure it is clear. F12 and F21, they are in opposite direction. What about their magnitude? See, if F12 and F21 are in opposite direction, obviously R12 and R21, they are in opposite direction. Means R12 caret and R21 caret, they are in opposite direction. Yes or no? Yes, it is. What about magnitude? See, G m1 m2, G m1 m2, R12, it is magnitude. R12 it is magnitude. Magnitude means distance between 1 and 2. R21, it is also distance between 2 and 1. Hello? Distance between 1 and 2. Distance between 2 and 1. So we know that, okay, here, R12 is equal to R21, is equal to distance between, distance between 1 and 2, is equal to distance between 1 and 2. Clear? So see, magnitudes are same. but direction R12 caret, R21 caret. R12 it is in this direction, R21 it is in this direction. Direction is opposite. Direction is opposite. Yes, it is opposite. So therefore we can say, okay, here magnitude are equal, but direction opposite. So therefore we can write. Magnitudes are same. So F12 is equal to F21. Magnitude, okay. But as direction is opposite, how to write its vector form? It is its scalar form. How to write its vector form? F12 is equal to minus F21. It is called its vector. And yes, it is according to Newton's third law of motion. Yes or no? Each and every object, action and reaction, they are of equal magnitude and opposite direction. Yes, their magnitudes are same, but the direction is opposite. Clear about this? Hello? Okay? Yes. You have to remember how to write this equation. F12 gm1 m2 upon r12 square r12 caret. F21 gm1 m2 upon r21 square r21 caret. And yes, one most important thing, r12 is equal to r2 minus r1. Then here what is r21? Here what is r21? Yes, here I will write. R21 is equal to it is r1 minus r2. R1 minus r2. Clear about this? So yes, it is vector form of universal law of gravitation. Clear? Remember, similar theory you will see in 12th for Coulomb's law, vector form. Okay, so yes, if you understand this theory, if you remember this theory, you can easily write vector form of Coulomb's law for electric charges. So yes, it is one theory, and yes, it is one important theory that you have to remember. And yes, for today, this is it.